Have you ever really thought about what stands between your personal information and, well, the rest of the world? It's way more than just a password. So, in this explainer, we're going to pull back the curtain on user security. We'll look at everything from the keys you use to unlock your digital life to the invisible rules that protect a company's most sensitive data. All right, we've got a lot to get through, so let's dive right in. We'll start with the human element, because, that's the biggest challenge. Then we'll get into how we actually prove we are who we say we are, what happens after we're in, and finally, how all these rules get put into practice. So let's kick things off with a big one. The question that probably keeps a lot of security experts up at night. Why is it that with all our crazy advanced firewalls and encryption, the human user, you and me, is so often seen as the biggest vulnerability in the whole system? Well, it really just boils down to a simple truth. The moment you get access to a system, you're basically handed the keys to the kingdom. The problem is, our very human habits can make those keys incredibly easy for someone else to grab. And come on, we're all guilty of some of these, right? Using the same password for our bank and our favorite food delivery app, or picking something super obvious like password 123. And sometimes the threat isn't even high tech. It could be as simple as someone literally looking over your shoulder as you type. Okay, so we've established that passwords by themselves are a pretty weak point. So what's the next line of defense? How do we build a better, stronger digital lock? The key isn't just about having more locks, it's about having different kinds of locks. And this is the whole idea behind multi-factor authentication, or MFA. You've probably heard that term, and it is absolutely a crucial layer of security today. These different proofs fall into three main buckets. First, there's something you know, which is your classic password or PIN. Second is something you have, like a physical key card. And third, something you are. Think your fingerprint. Real MFA combines at least two of these. Now, something you have isn't just about physical stuff. I mean, on the one hand, you have a physical token, like a military access card, but then you have the digital version, right? An app on your phone that spits out a temporary one-time use code. Both are things you physically possess. And then something you are takes security to a whole other level, a much more personal one. We're talking about your unique biological markers, your fingerprint, the scan of your face, maybe even the sound of your voice. This is the wild world of biometrics. So we have all these really powerful ways to authenticate. But how do we actually use them without making it impossible for regular people to log in? It turns out it's all a really delicate balancing act. This graph here really shows the fundamental problem. If you make a system too strict, you risk it locking out legitimate users. That's called the false rejection rate. But if you make it too loose, you start letting imposters in, the false acceptance rate. The perfect system finds that sweet spot right in the middle, at a point they call the crossover error rate. Okay, but how does this work on a massive scale, like in a huge company? Well, you need a central gatekeeper. And one of the most common systems for this is called Kerberos. And it's so perfectly named after the three-headed dog from Greek mythology that guarded the underworld. The absolute genius of Kerberos is that it stops you from having to flash your password all over the network. You prove who you are just once to a central trusted server. And in return, you get this secure temporary ticket. You can then show that ticket to all the other services to get access, all without ever revealing your actual password. Pretty smart, right? But here's the thing. Getting through the front door is really only the first step. Once the system knows who you are, it has to decide what you're actually allowed to do. And this is the really key difference between authentication and authorization. Think of it this way. Authentication is showing your ID at the door to prove you're on the list. Authorization is getting a special wristband that says, okay, you're allowed into the VIP section. So how do systems handle who gets to go where? Well, there are a few different approaches. You've got the super strict top-down model called mandatory access control. Then there's a more flexible one where users have more say. But honestly, for most places, the sweet spot is role-based access control, where your permissions are just tied to your job. So let's look at that first one, mandatory access control, or MAC. The best way to think about it is like a strict pyramid of information. Access is granted based on these formal clearance levels, top secret, secret, confidential. This is the kind of model you'll find in places like the military, where controlling information is everything. Role-based access control, on the other hand, is all about efficiency.
I mean, can you imagine trying to set permissions for every single employee one by one? No way. With this, you just create roles like sales group, give permissions to that role, and then when a new person joins the team, you just drop them in the group. Boom. They instantly have all the access they need. Okay, so we've covered a lot of the theories and the models. But how does this all actually get put into practice? Let's take a peek at how a system administrator actually sets the rules of the game.
It really all comes down to setting policies. These are the specific, hard-coded rules that the computer's operating system has to follow. An administrator can use tools just like this to turn those big security ideas into concrete commands that the system will actually enforce. And here it is. This is what that looks like in the real world. This is the control panel where an administrator can enforce all those password rules. Things like setting a minimum length or forcing you to use a mix of letters, numbers, and symbols. And you'll notice how each of these policies directly attacks those human weaknesses we talked about right at the beginning. Enforced password history stops you from reusing old passwords. Password complexity prevents those easy-to-guess ones. It's a systematic way to build a stronger defense, mostly against ourselves. And that leaves us with one last really crucial thought. As the tech to prove who we are gets more and more personal, moving from a password we know to a fingerprint or a face that we are, we all have to ask ourselves, where exactly do we draw the line between perfect security and our own personal privacy?